Hello everyone, first microphone test, can you hear me? So hello everyone, due to a little delay the response has just arrived. Hello everyone, welcome to the launch mirror and discussion of Progress 67, a modified Soyuz that serves as a resupply vehicle to the International Space Station. It is being launched on a Soyuz U, a Russian launch vehicle that we all know, as it's the only launch vehicle that, in a different version, is right now capable of launching humans to space. The vehicle is, as I said, a modified Soyuz built for unmanned cargo transportation. It can carry about 2,400 kilograms of payload, including air supplies or oxygen supplies, food and water, as well as research equipment and other supplies or equipment that is needed on the International Space Station. It has its own propulsion system, so after the Soyuz standard three-stage vehicle launches it into a low Earth orbit on the same inclination as the International Space Station, it will then maneuver to the International Space Station on its own and dock in about 2 days, which I will also cover. From then, the next coverage will be the SpaceX launch 1 day later. Of course, as always, the live stream can be run back. My English skills are leaving me right now again, but you can go to the bar below the video, like in every YouTube video, and skip back through the live stream and watch things again. And the live stream, as well as the full coverage, will be available afterwards as well. Uh, Also, the anti-space conspiracist, which who you might be seeing in the chat right now, will also record the launch and probably put it up on his channel. And we got over to NASA TV's coverage.
From the International Space Station Flight Control Room here at
I will
the
try
Johnson
not to
Space Center
interrupt
in
too
Houston,
much
where
and
the Orbit 1 team of
just
flight
leave this kind
controllers
of
is
running.
on duty here at this hour, ready for the launch less than 20 minutes from now of the Soyuz 2.1A booster down at the Baikonur Cosmodrome in Kazakhstan to send a Progress, an unpiloted Progress 67 cargo craft en route to the International Space Station, a 2-day journey with a docking scheduled on Friday morning.
The normal LED is blinking now.
You're looking at a balcony view of a camera at the Russian flight control room in Korolyov outside of Moscow, where the Russian flight control team is keeping tabs on the countdown, which will head for the launch of the Progress atop its Soyuz booster just 19 minutes from now. Down at the Baikonur Cosmodrome in Kazakhstan, there is a live view of launch site 31, where the Soyuz booster stands fully fueled. It was fueled several hours ago. The Progress is shrouded in the upper stage, the third stage of the Soyuz booster, ready for an 8-minute, 45-second ride to its preliminary orbit after the Progress itself is separated from the third stage of the Soyuz booster. It will deploy its solar arrays and navigational antennas and begin a series of pre-programmed automated rendezvous burns that will begin a 2-day journey to the International Space Station and a final docking to the aft port of the Zvezda service module on Friday. We'll talk more about that in a moment. The Progress is loaded with 3 tons of food, fuel, and supplies for the Expedition 52 crew on board the International Space Station. The breakdown of that cargo includes 1,940 pounds of propellant, 51 pounds of oxygen, 53 pounds of air, 926 pounds of water, 3,069 pounds of dry cargo in the form of spare parts and other supplies for the crew on board the orbital outpost. A total of 6,039 pounds loaded into that Progress vehicle, 3 tons of supplies ready to make their way to the International Space Station.
Power.
The Soyuz booster was fueled several hours ago. About 30 minutes ago, the gantry arms that had enveloped the Soyuz since its rollout to the pad back on Sunday, they were lowered to expose the vehicle. There are 2 sets of ground umbilicals still buttressed up against the side of the Soyuz booster. The first of those 2 umbilicals will fall away, drop back, and be retracted about a minute before launch. The second about 20 seconds before launch. That will initiate the automated engine start sequence that will result in the Progress liftoff. Down in Baikonur, it is a blustery, overcast day with some rain showers, temperatures about 80 degrees Fahrenheit, but the Soyuz is ready to begin its journey just 16.5 minutes from now. At launch site 31, the integration facility is not far from the launch pad, much closer than it is at site 1 for a manned Soyuz launch. And on Sunday, the Soyuz booster and the Progress vehicle, horizontal on a rail car, was transported a short distance from the integration building to the launch pad. You see in this series of photos, courtesy of Roscosmos, the Russian Federal Space Agency. Once the Soyuz booster had reached the launch pad, it was hydraulically lifted into its vertical position on the pad, and those gantry arms that you see there were folded around the vehicle to permit launch pad engineers access to hook up power and fuel lines and data cables to the vehicle for the final 3 days of processing that will lead to its launch just 15.5 minutes from now.
Give you a picture if you need, because they're going to be used for this particular device only. So it makes pertinent sense to store them here.
Тогда пока забираем свое предложение, дальше посмотрим, может там, тогда где тот прибор находится. Потому что за эту панель сложно заглядывать. Светильник надо демонтировать.
Ну, для справки мы вот это вот СУБК с прибором 74
As the countdown continues on track for launch of the Progress vehicle just over 14 minutes from now, on board the International Space Station, the Expedition 52 crew has begun its workday. They are receiving a feed of the launch coverage up on board the station so they can keep tabs of the latest in the series of cargo ships about to take flight on a 2-day journey to the International Space Station. The station is currently flying over the South Pacific at an altitude of 258 statute miles, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. At the time of launch, the station will be flying over the southern Atlantic just to the southeast of Uruguay. You're looking live again at the upper stage of the Soyuz booster. That's the launch shroud within which is the Progress 67 cargo craft, again loaded with 3 tons of food, fuel, and supplies for the Expedition 52 crew aboard the International Space Station. The flight plan calls for an 8-minute, 45-second ride to orbit for the Progress vehicle. Once it is separated from the third stage of the Soyuz booster, it will deploy its solar arrays and navigational antennas. It will be automatically controlled through pre-programmed commands. Later in the day, there'll be 2 rendezvous burns to increase the altitude of the Progress as it begins its trek toward the station, most particularly to adjust the perigee of its orbit, to raise the perigee of its orbit. Additional rendezvous maneuvers over the next 2 days will bring the Progress into the vicinity of the International Space Station early Friday morning. The Progress, if all goes as planned, will automatically dock to the aft port of the Zvezda service module at 6:42 a.m. Central Time, 7:42 a.m. Eastern Time on Friday morning. The launch milestones that we'll be reporting over the next few minutes after liftoff include first stage separation of the Soyuz booster, 1 minute 57 seconds into flight. At that point, the Soyuz and the Progress will be 30 miles in altitude, some 73 miles downrange from the Baikonur Cosmodrome. The second stage engines will be firing. They will shut down at about the 4-minute 37-second mark. Second stage separation will follow just a few seconds later, followed by the launch shroud jettison. The third stage engine will fire just in what is called a hot fire maneuver. Basically, the third stage ignites before the second stage shuts down. That's the sequence that Soyuz boosters use for its propulsion of a payload, or in this case, the Progress vehicle, to orbit. If all goes as planned, third stage shutdown will occur at 8 minutes 45 seconds into the flight, followed a few seconds later by the third stage separation. The Progress then will be flying on its own to deploy its solar arrays and its navigational antennas. We're just 11 minutes away now from launch. Everything continues to go as planned with all of the pre-launch activities down at the Baikonur Cosmodrome in Kazakhstan. Launch Site 31, where there have been 2 manned Soyuz launches recently in the last few years. Manned launches typically occur on Site 1, which is the launch pad from which Yuri Gagarin lifted off on April 12th, 1961 to become the first human to fly in space. This launch site, 31, is more commonly used for Progress resupply launches. And it is about a 45-minute drive or so from Launch Site 1, the 2 launch pads quite a distance apart from one another. Again, the weather is overcast. We probably will not see the rocket for very long today. Hopefully, we'll get real-time animation that is provided from Mission Control in Korolyov after the vehicle is no longer in the field of view. Nine minutes from launch, everything proceeding normally. Onboard systems have been switched to onboard control. The next two milestones will occur within the next few minutes. That will be the boosters in the first stage, the booster tanks being pressurized for flight to optimize the flow of fuel and add structural support to the rocket on the pad. About a minute and a half before launch, the ground propellant feed will be terminated. Once the Progress reaches the International Space Station on Friday morning for its automated docking to the aft port of the Zvezda service module, it will join another Progress that has been on the station for the past few months, that the Progress 66 cargo craft, which is docked to the Pirs docking compartment on the Earth-facing side of the Russian segment of the International Space Station. You see in this graphic the current configuration of the International Space Station. That Progress 66 craft will remain docked to Pirs until July 20th, when it will undock and be deorbited for a destructive reentry back into the Earth's atmosphere. And again, Progress 67, as of Friday, will dock to the aft port of the Zvezda service module. You see where it will reside. It is scheduled to remain on the International Space Station at that port until December. T-minus 7 minutes and counting.
Of course, while the most important modification of the Progress compared to the Soyuz is that it is built to be unmanned and automated, or semi-automated and remote controlled, but operate completely unmanned. The most visible modification is that it is not built for re-entry. It does not survive re-entry.
That's a good view of the one of the two umbilicals still buttressed up against the side of the Soyuz booster. That umbilical will retract just under a minute before launch. A second umbilical will separate from the booster. That will initiate the automated launch command sequence for the engines on the first stage of the Soyuz booster. T-minus 6 minutes and counting.
The Progress thus lacks the characteristic Soyuz separation shape. You can very clearly see in the Soyuz shape how it is built and separated into the service and re-entry capsule and habitat module, and this separation is kind of lacking in the Progress, as it is not built to survive re-entry, which is the most visible difference in the shape between the standard manned Soyuz and the Progress resupply ship.
Coming up on the T-minus 5 minute mark.
Ground measurement system is activated.
Inside 5 minutes now to launch. We're coming up on the purging of the fuel lines and the other elements of the rocket engines, purged with nitrogen to fireproof them by removing vapors of fuel and oxidizer.
And while the Soyuz rocket uses a kerosene-oxygen-based fuel mixture, the Progress spacecraft instead uses fuels or propellants.
T-minus 4 minutes and counting. Everything proceeding normally for an on-time launch. The actual launch time will be 4:20 and 13 seconds a.m. Central Time, 3:20 in the afternoon in Baikonur at the launch site.
The Progress uses nitrogen-based hydrogen and oxygen compounds, which exact English names are not really that easy to pronounce for me because I only know the German names, but these are nitrogen-based compounds and they're not really as made up for efficiency or power as the whole thruster system is. The thrusters of the Progress service module are of course built more for precision than efficiency or performance. They can be reignited almost
T-minus 3
limitless
minutes and counting.
and controlled in split seconds to actually maneuver the spacecraft into the docking
valves
port.
through which evaporated oxygen escapes from the fuel tanks into the atmosphere have now been closed, and that substance now being drained back into the tanks. Standing by for the pressurization now of the fuel and oxidizer tanks, everything proceeding on track. Two and a half minutes until launch.
Booster propellant tank pressurization.
The booster tanks are now being pressurized. The International Space Station flying 258 statute miles over the South Atlantic, moving from southwest to northeast. Coming up on 1 minute before launch. The automated sequence start for the rocket's functions now underway.
Vehicle to internal power.
Soyuz booster now on internal power, coming up on the 30-second mark. And the first umbilical now beginning to retract from the side of the vehicle. Standing by for engine sequence start, T-minus 10 seconds.
Ignition.
The launch command has now been issued. Engine start underway. Turbo pumps coming up to flight speed.
Engine turbo pumps at flight speed. Engines at maximum thrust.
And liftoff. Liftoff of the 67th Progress resupply vehicle bound on a 2-day journey to the International Space Station. Roll, pitch, and yaw program in. Booster parameters are all normal.
Parameters are normal.
And we have liftoff with beautiful coverage.
First stage engine functioning normally.
Good visibility and good daylight, at
Soyuz
least for the
booster
liftoff
arcing
itself.
out to the northeast from the Baikonur Cosmodrome.
And I will try to almost live translate values that are read out to the metric
Engineers at the
system.
blockhouse in Baikonur report that the vehicle is stable. All engine parameters are normal.
0.013.
1 minute into the flight.
12
2013.
Now receiving animation generated by telemetry from the vehicle.
And all parameters are normal.
One minute, 15 seconds into the flight.
All nominal.
All parameters are normal. Good first stage engine. First stage engine shutdown and separation of the first stage coming at 1 minute, 57 seconds into the flight.
Parameters are normal.
One minute, 40 seconds into the flight.
The booster parameters are normal.
Booster parameters are normal, standing by for first stage engine shutdown and first stage separation.
Rotation parameters are normal.
Strap-on boosters have separated.
Can you monitor the vehicle? The side pods separated. Vehicle is stable.
Vehicle stable on its second stage engine now.
Now the
Good
parallel
engine performance on the second stage. 2 minutes, 25 seconds into the flight.
Booster parameters
the
are normal.
parallel first
system-
or zero
control system.
stage
All
has
control
been
systems
separated.
are reported to be normal from the blockhouse in Baikonur. Once the Progress reaches orbit and separates from the third stage of the Soyuz booster, operation and oversight will be controlled from the Russian Mission Control Center in Korolyov outside Moscow.
We have now
Flight
about,
proceeding normally, coming up on the 3-minute mark.
we have about 2 minutes remaining in the second stage burn until the second stage will separate
booster
and the
control systems
third
and
stage
parameters are
will
normal.
ignite. Before that,
Everything
of course, because
reported
it's
right
hot
down
staging.
the pike. Everything is normal. All parameters are normal.
As you can
Vehicle
see,
stabilization is normal.
as you can see at the top of the screen, about 100 seconds remaining in the second stage burn.
Just over a minute left in second stage performance.
Operating nominally.
Engine performance is nominal. Good reports from the blockhouse at Baikonur. Progress
Control system
carving a
parameters
path
are normal.
towards its preliminary orbit. Three minutes, 48 seconds into the flight. Less than 5 minutes of powered flight remaining.
Vehicle is stable.
Vehicle stabilization is normal. Engine performance is normal.
Your pitch roll parameters are normal.
Yaw, pitch, and roll all reported to be normal. The progress in the atop the Soyuz booster, traveling a true course so far to its preliminary orbit at the 4.5-minute mark. We're standing by for second stage shutdown and second stage separation.
Booster parameters normal. Repress reported. Second stage separation.
And we have confirmation of second stage separation, and we have launch shroud jettison. As you can see from this telemetry generated animation, just over 5 minutes into the flight, everything proceeding normally. The Soyuz booster on its third stage now, sending the Progress toward its preliminary orbit. We're about 3.5 minutes away from the end of powered flight.
Third stage.
We have
The
second stage.
Soyuz booster and the Progress more than 100 miles in altitude, more than 200 miles downrange from the Baikonur Cosmodrome, traveling almost 10,000 miles an hour.
That's over 150 kilometers in altitude, so it is far above the common line and in an altitude where an almost stable orbit is possible,
Parameters.
All vehicle parameters are reported to be normal.
which is good for a parking orbit. It's the lowest altitude at which almost stable orbit is possible.
350 seconds into the flight, all nominal.
6 minutes into the flight, about 2 minutes and 45 seconds of powered flight remaining.
Your pitch and roll parameters are normal.
During the second stage separation, the hot staging was, of course, not exactly shown in the
All
animation.
booster parameters are reported to be normal.
But as you could see, the
Soyuz booster on the singular power of its third stage engine.
Stage thrusters.
The progress, as you can see in this animation, now exposed to the environment of space as it heads to its preliminary orbit. 6 minutes, 40 seconds into the flight. 2 more minutes of powered flight remaining.
The vehicle is stable.
The fairing separation was just after the second stage separation. This is not always the case, depending on what kind of orbit the Soyuz is aiming at.
Flight is normal.
But in the
flight is reported to be
low
normal.
orbit Soyuz
7
and
minutes
progress
into the
flights,
flight. 1
this is
minute,
the case.
45 seconds left in powered flight.
Your pitch and roll parameters are normal. Third stage thrusters operating normally.
Third stage engine reported to be operating normally. Everything in good shape so far. Launch time was right on time at 4:20 and 13 seconds a.m. Central Time.
.450 seconds into the flight, all nominal.
7 minutes, 45 seconds into the flight. 1 more minute of powered flight.
All booster control parameters are normal. Third stage thruster operating normally.
Just over 8 minutes into the flight. So far, so good. Third stage engine performing normally.
All control system parameters are normal. Vehicle stable.
The vehicle very stable. About 20 seconds of powered flight remaining. Standing by just a few seconds from now for third stage shutdown and third stage separation.
Third stage shutdown.
We have confirmation of third stage shutdown and spacecraft separation. Standing by now for the deployment of the solar arrays and navigational antennas.
ISM first set activated. Antenna deployment commands of Group 1 and Group 2 issued. All appendages are deployed. Copy that. TDU parameters are normal.
And you're looking at a view of the Russian flight control room in Korolyov, Russia, just outside of Moscow. We now have confirmation of the nominal deployment of the Progress 67 solar arrays and navigational antennas, completing a flawless ride to orbit for the Progress cargo ship atop its Soyuz booster. And there you see the external camera view on the Progress, just a momentary view. That television camera boom was deployed as planned to provide an external television view for the Russian flight controllers in Korolyov, as well as the view that will be transmitted during the terminal stage of the rendezvous, leading up to an automated docking of the Progress vehicle on Friday morning.
Course test, okay. Copy. ISM settings uplinked.
Again, everything proceeding perfectly with the Progress 67 craft. You saw a momentary view from the external television camera on the resupply vehicle. that has now reached its preliminary orbit following a textbook ride to orbit atop its Soyuz booster. The launch occurring at 4:20 and 13 seconds a.m. Central Time, 3:20 p.m. Baikonur time at the Launch Site 31 complex at the Baikonur Cosmodrome in Kazakhstan. It was a flawless ride to orbit, 8 minutes and 45 seconds to deliver the Progress into its preliminary orbit. There will be 2 rendezvous burns executed later today, automated pre-programmed burns to raise the perigee of the Progress's orbit as it begins its 2-day journey to the International Space Station. So with that, we'll wrap up our coverage. The Progress 67 safely in orbit, headed for a delivery mission to the International Space Station, and the 3 crew members on board the complex, the station commander Fyodor Yurchikhin, and NASA astronauts Peggy Whitson and Jack Fisher. Progress will arrive on Friday morning. We'll bring that to you live here on NASA television. Our coverage on Friday of the Progress docking will begin at 6 a.m. Central Time, 7 a.m. Eastern Time. Docking is scheduled at 6:42 a.m. Central Time, 7:42 a.m. Eastern Time. And the Progress, as we mentioned earlier, will automatically link up to the aft port of the Zvezda service module. So with that, we'll wrap up our coverage. Progress 67 safely in orbit en route to the International Space Station. This is Mission Control Houston.
Okay, we have seen a great launch and a successful separation of spacecraft. I will now begin to wrap up the launch cast. I will wait for a few more questions and then conclude the live stream. The next live stream will be in 2 days when the Progress docks to the ISS, and 1 day after that with the Falcon 9 Bulgaria sub launch. I will unfortunately not cover the Long March launch, as the Chinese launches are always a bit difficult to get live coverage of, but I will see if I can find footage after the launch. And as requested, I might of course try to pronounce the fuels of the Progress spacecraft. I will pronounce them in German first, as that's what I know, and then I will comically attempt to pronounce them in English. Now, the actual fuel is 1,1 dimethylhydrazine in German, or unsymmetrical dimethylhydrazine in English. and as oxidizer it uses Distickstoff-Tetroxid or dinitrogen tetroxide, which is actually very similar. Like the fuel, it's pretty much the same word, just phrase by phrase translated. So I've followed that request too now. The budget allocation of different countries to the ISS is a bit complicated, and it also depends on local politics a lot. But generally, it's actually mostly NASA and Roscosmos doing the main infrastructural part, the actual necessities, and other space agencies, while also giving money, mostly contribute in other additional ways. It's mostly decided on a case-by-case basis, though. As for the German-English language difference stories goes, actually, if you thought chemistry was difficult in physics, it gets a bit more tricky, as this is often the case with German and English, I find. Though maybe that's because they're the only two languages I know, but there are often words that sound very similar in both languages, and sometimes they mean almost the same thing, but sometimes words sound very similar and mean different things, which of course can lead to misunderstandings and funny moments in English lessons. But in physics, many physics and mechanics terms have this kind of problem, and so I've made a lot of mistakes in English texts or English discussions about physics, considering things like momentum and torque and such, because they are easy to mess up between English and German. I'll now be away for a few minutes, or in another tab for a few minutes to set up the YouTube planned event, so that I kind of have the planned pinned event for the progress docking in 2 days. Then I'll come back and look for a few last questions, and then probably close the live stream. However, the almost kind of 24/7 ISS live coverage will continue, and you can always ask questions in the comments or in the chat of the almost 24/7 ISS Earth viewing livecast. So with the ISS moving into dark, I will close this version of the live stream. I will then quickly rearrange it and be back up in a few minutes with the almost 24/7 ISS Earth viewing live stream. We can, of course, keep chatting there. So in a few seconds, I'll stop this stream and be back in a few minutes. See you.